So some experimenting. Very basic setup right here, but just kind of learning ins and outs of the hardware that I have. So I've got, this is just for bench testing. It's a 30 amp capable 12 volt power supply. So this 12 volt power supply is feeding into this unit, which is a 12 to 48 volt nominal boost converter. The 48 volt out is adjustable via this potentiometer here. So I've got this guy connected to this pack. So this battery pack can achieve 58 volts if I recall correctly, but I only want to charge it to no more than 54 volts for my system. So this guy can adjust based on the way that or how far I turn this potentiometer in here to 52 volts. Let's see here. Just resetting my voltmeter. Okay, so right now the voltmeter is reading 48.6. So system voltage at the 48 volt level between here and here, 48.6. And I'm looking at about 8.8 amps coming from the 12 volt power supply. So I think it's set at 13.5 volts. But long story short, power's going in, being, let's say, boosted up in voltage level and continuing on to charge the battery pack. That's the fundamentals of the charging system that will be in the vehicle. And I'm trying to learn how this guy behaves in different conditions. So pack was originally at just below 48 volts. And so adjusting the output voltage on this thing, which is this guy here. So if I turn them down a little bit, right, there's 0 volts. So what that means is I've turned the target voltage on the boost converter below the voltage that the pack is at. So pack is currently at 48.5 volts. If I turn this guy counterclockwise, very slowly, you'll see the amps begin to kick up. Sometime here. Oh, there they go. There's 7.5 amps. So it is effectively charging that battery because the boost converter is trying to bring the battery to a higher voltage than it currently is. And that the current will continue to drop as the voltage begins to reach, the voltage of the battery pack begins to reach the output voltage of the converter. But if I turn this more, you'll see this current will ramp up to a maximum. There we go. So yeah, this guy will only put out 35 or 36 amps, but not for long because there's a breaker here that will flip. So I've been turning him down to, let's say, 30 and letting him run. Long story short, I think this voltage converter is fundamentally a bit too simple for the charging logic, to support the charging logic that I need in the vehicle. I didn't expect that this thing would handle the let's say target voltage and current in this fashion, but it does. And so I'll ramp it up a bit more to about 30. Well, you'll see here if I keep it here at 35, 36 amps for too long, this built-in breaker will flip, which is good. but I don't want to risk, for something as simple as 30 or 35 amps on the 12 volt side, I don't want to risk having a mechanical disconnect, because I need this thing to work on a regular basis. So I'll talk with SEC America, see if they can provide something that works a bit differently. There it is. The breaker flipped here. I think it's a 30 amp breaker. And so it heats up and flips. So if I reset him and adjust this back down, this is again the target voltage. That'll be safe enough to keep the thing charging. So the battery pack is currently 48.9 volts with a BMS at the bottom, keeping all the cells happy. So no worries about the battery pack. It can, like I said, it can go to 40 or 58 or 59 volts, something like that. Well above the voltage this thing will put out. So no concerns there. But testing. That's what I'm doing now.